Hey guys, today I'll be going through the structural exam problem that I found so many of you were struggling with. So here's the exam problem. So using the beam cross-section below with the area moment of inertia 24.17 inch to the fourth, experiencing a 150 pounds shear loading. A. Calculate the shear force experienced 1.75 inches above the horizontal neutral axis. So here's where you want to calculate the shear force. That is 1.75 inches above the neutral axis right here. So how are you going to do the first part of the problem? Well, we all know the formula for the shear force that is given right here. We also given the moment of inertia 24.17 inch cubed, and the shear loading V is going to be 150 pound force. So what we are missing? We're missing the Q, we're missing the T. How do we gonna find those two? And those are the two that so many students couldn't find the answer in the last exam. So here I'll show you how to find out these two values. So Q is the sum of AY. A is the area of the cross of the section that you want to calculate, and Y is the distance from the center of that section to the point to the axis that is you are doing the shear force on. In this case, we're gonna divide the first. So basically, what we are doing is to find out the shear force acting on this area right there. And what I'm gonna do is to divide all of these into three sections. I call it just 1, 2, and 3. And remember, 2 and 3 are identical, so I'm just gonna multiply by 2 later. But for the first section, number 1, the area of the first one is gonna be 2.5 times 0.5, and the distance from the centroid, that part, to the axis that you want to calculate the shear force is going to be 1 based on the given dimension right here. So this is 1.25 right there, and the distance from the cap to the top to the centroid, the cap is 0.25, and that's why the distance from that axis to the centroid is 1. Similarly, we're going to do the same thing for these two sections. I'm just going to multiply by 2 over here. The area is going to be 0.25, that is the width, times the height, it's going to be 0.75, and you also want to multiply the distance from the centroid to that axis, which is going to be 0.375, and this is going to give you 1.39 inches cubed. So we got the Q. How about the T? Remember, the T is the thickness of the cross section at the point that you are calculating the shear force. So if the shear you are calculating go through this axis right there, then the thickness of that section is going to be what? It's going to be that part plus that part. So T in this case is going to be 2 times the width is 0.25. It's going to be turned out to be 0.5 inches. With all of these given values, you can just easily put in the equation up here. Oop, my bad. So sorry, this is gonna be 150, and this is gonna be 24.17. times 0.5. It's gonna give you 17.25 pound inch square, which is the shear force experienced 1.75 inches above the neutral axis. For part B, where will the shear force be maximum in the section? So you want to find out the maximum shear, and remember the shear, it depends on the Q, which it depends on where you are calculating the shear force. So in order to get the maximum shear, you want to get the maximum Q. And if you look at the formula for the Q, which is equal to the sum of AY, maximum Q is gonna happen at maximum Y. So maximum Y will be the distance from the top to the centroid of the beam of this cross-section area, simply because this cross-section area is symmetric around the centroid, around the neutral axis. So the maximum distance of the Y is going to be from the top to the centroid. And from that we can conclude the shear force will be maximum at the neutral axis. And for part C, does this formula accurately model the behavior of the shear? Well, the answer is no. The reason why is because, as you can see here, you got a difference in thickness between the side and the cap. So when the shear flow from the wall into the cap, due to the difference in thickness, this model is not going to be accurately model the linear shear flow from that part to that part. So the answer is no.